Here I just want to discuss what are parallel vectors. Now, if you talk about parallel lines, then you have lines that have equal gradients, right? That's true. So now, when we talk about vectors, if vector A is parallel to vector B, then that means that we can express, that we can express vector A as some number multiplied by vector B. Or we can express vector B as some number multiplied by vector A. And keep in mind, I'm not saying like these are the same thing basically. So I'm just saying like you multiply some number with that. So now let's look at vector A, which is given by 1, 4, and 3. And let's look at vector B given by 1 over 4, 1, and 3 over 4. Now, are these vectors parallel? Let's see. Now, if they are parallel, that means we can extract some number there. Okay, fine. So now, vector B, you can basically see that here we divided by 4 in the denominators here. So what you're going to do is like, you're going to say this is 1/4 of 4 vector B. 1/4 of 4 vector B. The reason I'm doing that is like I'm trying to get whole numbers out of that. So now, I'm going to have like 1 over 4 multiplied by, what's 4 vector B? So you just multiply every component by 4. What's 1 over 4 by 4? That's 1. And what's 1 by 4? That's 4. And what's 3 over 4 by 4? That's 3. So are these vectors parallel? Yes, because as you can see, this is basically vector A. So you have some constant multiplied by vector A, giving you vector B. So that's the idea of parallel. So now let's look at vector A, given by 0, 1, 1. And vector B. Okay, here I concluded that vector A is parallel to vector B. So now, here let's look at 1, 5, 7. Are these two vectors parallel? No, because you cannot express this as a multiple of the other vector. So how you can look at it is like, let's say you want to get 5 here in A. The only way you can get 5 in A is if you multiply every component in A by 5. But notice that if you multiply 0 by 5, you will not get 1. So that means that vector A is not some constant multiplied by vector B. And therefore, that means that the two are not parallel. So the reason I'm showing you this is like we're going to end up having to discuss like how to get an equation of a vector. An equation of a line. An equation of a line when this is like an initial coordinate and t will denote some sort of a gradient and v will be a vector parallel to that line.